Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you back to the lecture series of course material on transportation engineering 2. In the previous lectures, we have already discussed about the elementary sides of the various cases, like what are the permanent ways, what are the specifications, the gauges being used on the Indian railways, the resistances offered by the tracks, and the stresses or the bending moments etc. being caused in the different components of the track. Now, we are starting with the other aspect of the railways, that is the components of tracks. In the today's lecture, we will be covering the aspects related to rails. Some of the aspects which will not be covered today will be covered in the subsequent lectures. In the rails, we will be taking the functions of the rails, the type of rail sections, the selection of rail section, the length of rail, the tests conducted on rails, and rail deformations or defects. These are the things which we will be taking up in the today's lecture. Starting with the functions of the rails. The rails are provided so as to have a continuous and leveled surface on the track. Rail is a surface which provides the surface for the movement of wheels. If this is not continuous and if it is not leveled, then obviously it is going to create some disastrous or hazardous conditions, as we have seen in the case of the stresses or the moments which can be induced in any of the component of the tracks in the previous lectures. Another thing is that it should require to have a smooth surface so that the frictions are as low as possible. Then it also provides the lateral guidance to the wheels. In the case of the wheels, as we have seen maybe in the coning of the wheels or any other diagram where the interaction of the wheel with the rail is being shown, what we found is that the flanges are provided on the inner side of the rail section to the wheels, so that when there is a lateral movement of the wheel in any outward or inner direction, then the wheels are not going away from the rail section. So, that is how the rail sections are providing lateral guidance to the wheels. If this lateral guidance to the wheels is not available, then there will be a derailment condition because of the slippage of the wheels over the rail sections. Further, it bears stresses which are developed due to vertical loads, thermal loads or braking efforts. In the previous lectures, we have seen that there are stresses which are caused because of different reasons. All those stresses needs to be counteracted or to be taken care of. The rail is one that system which has to bear the stresses which are coming directly from the wheels to it. So, that is why whatever type of stresses are being developed because of any of the reasons, they should be able to bear them without failure. Further, they should be able to transmit those stresses or loads which are coming from the top, that is from the wheels, to the lower areas to a greater area below. If they are not transferring the load to a greater area below, then because of the concentrated load conditions or the pressures being induced at any of one location, there will be chances that there is a permanent sort of a deformation get created at that location. And if there is any permanent deformation which is getting created at the location, finally it is going to culminate into surface irregularities and the failure of the track. Now, we are looking at some of the requirements of the rail sections. The very first thing is the composition of the steel should be proper. whatever are the materials which needs to be mixed so as to form that rail section, in whatever proportions they needs to be mixed, in whatever grades they needs to be mixed, that should be proper. Then only the proper strength properties of that rail section will be achieved, otherwise there will remain certain sort of defects in that. Another thing is that the rail section should be economical in nature. When we say it should be economical in nature, we have to look at three components along with economy. It should not happen that we provide a so small rail section that it is not in a position to take up the loads which are coming from the top, or it is not in a position to sustain or to provide the guidance to the wheel system. The three aspects which needs to be taken care of are strength, durability and stiffness. We cannot compensate, or we cannot remove, we cannot eliminate, we cannot reduce any of the aspects related to these three things. The strength which is required should be there, they should be durable enough. It means whatever are the effects of the temperatures or other corrosive effects because of the location of the rail sections being provided in certain areas, they should be able to sustain all such type of actions, and they should be stiff as far as possible so that they can sustain the types of the loads which are coming from different locations, from different directions in eccentric conditions. If any of these three aspects are not taken care of, or there is something being left in the design procedure, then it is going to culminate, it is going to finally reach the failure condition of that rail section. So, we have to get the economy along with preserving these three things, that is the strength, durability and stiffness. Another important thing in the design of the rail section is that its CZ should be as near as possible to the center of the height. Now, if the CZ is very near to the center of the height, then it will help in the balancing of the tensile and compressive stresses. If this balancing of the stresses is not there, and if any of the stress is more, then it is going to create its effect in terms of the different types of the defects which can get induced into the rail section. So, as to remove that type of effect getting induced in, we have to make sure and ensure that the CZ is coming very near to the center of the height. Now, this is one of the rail section which is being shown here. Here this rail section has three components. This component is known as the head, this is known as web, and this is the foot. This is another sort of a rail section where again this is head, this is web and this is foot. This section where we are having a larger foot area is known as flat bottomed condition, whereas in this case where it is not having a larger area, it is quite similar to what is being provided at the top, that is the head. It is termed as the bull headed condition or double headed condition. So, what we can see is in this case that we have to design this area, we have to design this web area as well as the foot area. So, when we are talking about the strength, it means the head should be sufficiently large enough so as to take the loads which are coming from the top and dissipate them. Web should also have its sufficient strength so that because of the lateral loads which are coming from this direction, this should not break down because it is a thinner area, and foot should be able to provide the loads to a wider area, which is possible basically in this section because this is the total this width which is available through which the same amount of load will get dissipated, whereas in this case this area is so small. Now, keeping in mind this aspect, we can look further. The balanced distribution of material is to be done in head, web and foot. This is another important thing. What is the total amount of the material which is to be put in these three sections? As we have seen, the head is the section which is taking directly the total loads which are coming from the top. Therefore, it has to be a little wider. The web is to be designed in such that it is stiff in nature, and foot should be able to sustain the twisting conditions as well as should be able to distribute the load to a larger area. And looking at these three aspects of these three sections, the distribution of the material has to be done. The next thing is that we have to look at the economical and balanced distribution of metal, where the head should be able to have adequate depth so that the vertical wear, if any, is there is not creating an effect by which we have to remove that rail section very frequently. Another thing is that it should be wide enough so that the running surfaces, whatever running surfaces of the wheels are there, they should have sufficient movement over the top of that. And a lateral stiffness obviously has to be there, because of the flanges are hitting the side of the rail head, and when they are hitting the side of the rail head, then the stiffness has to be there. If that is not there, it will break down at the point of contact of the head with the web. Another thing related to the rail section is the height. It should have sufficient vertical stiffness and strength. Looking at the total amount of the loads which are coming in the lateral direction, we have to look at what are the bending conditions which will be created, and on the basis of this height, those bending values can be computed. So, we look at the stiffness and the strength aspect and design it. Further, in the case of the web, the thickness has to be designed, because it has to resist the lateral loads which are coming from the top in terms of the flange action, and at the same time the rigidity, fractional rigidity has to be there. So, this is design aspect of the web. In the case of the foot, because it is a point at which it is being connected with the sleeper, it should be stable enough, and so as to have that stability, it should remain wide in nature. So, if it is wide, there will not be any overturning of that material, of that component. The next thing is this thickness. Now, thickness is to be provided because there are stresses which are induced at this level of connectivity. The foot is connected to the sleeper using fastenings. If it is not thick enough, then it will break down very easily and there will be a failure of the system. In this region, it should be able to withstand the vertical and horizontal forces. After giving allowances for different type of durability aspects like corrosion, the effect of corrosion which can reduce the size of the section. The next thing is we are talking about the fishing angles, where the design of bottom of the rail head and the top of the rail's foot, they have to be designed in such a way that whatever fishing plates are provided at the side, they get fit in. If they are not getting fitting in, then there will remain some gap between the fishing plates and the web of the rail section, and because of that there will not be proper transmission of load from rail to the fish plates. So, the location at which the head is connected to the web or the foot is connected to the web, at that point whatever curvatures have been provided, at that level the fishing angles have to be designed in that form, so that proper connectivity is maintained. And another point is that the fillet radii should be large, so that the concentration of stresses can be reduced. Now, looking at the standard sections, what are the types of the sections which are available to us so that we can use them? There are three types of rail sections. One is double headed rail section. This double headed rail section is also known as dumbbell section. This is a sort of exercising equipment dumbbell, where there is a thinner section in the center which is held in the hand, and then there is a thicker section on both the sides which are same in nature. It means they are having the same sort of dimensions. So, it is designed to use from both the sides. The philosophy behind designing of that type of section was that if there is wear and tear at the top surface of the rail head, then we can just make it opposite, that is make the top bottom and make bottom top, so that we can use it from the other side. But what was observed, that because of the load conditions and because of the connectivity of the bottom of that rail section with the sleeper through fastenings, some indentations are caused in that level, and if you are turning it towards the upside, then these indentations will create surface irregularities, and therefore, the running of the wheels will become difficult. It will not be smooth in nature. Then another type of rail section which was used looking at these aspects was bull headed rail. In the case of bull headed rail, the head was made a little more thicker, and stronger as compared to the previous one, where the both head and foot were of same section. And it means some more material is being added to the top of the head. The philosophy here was that even if there is some wear and tear in this case, it will remain as such and will be remain in continuous use. Finally, the third type of the rail section which came was the flat footed rail. This flat footed rail is also known as Vignal's rail, after the name of its inventor Vignal. Under heavy loads, in this case the foot is found sinking in the wooden sleeper. That was the case of the previous two one, because the sections which have been provided at the bottom, that is as a foot, were of a smaller section, and if the heavy loads were coming at the top, then they were going inside of the sleepers. Initially the wooden sleepers have been used, and so it was found that they were penetrating the wooden sleeper, whereas now if we have the flat footed rails, then this is not the case. Another thing is that they were requiring the bearing plates for load distribution, but in this case of the flat footed rail, because the larger area is available, therefore generally the bearing plates may not be required, and they are now most commonly in use in India. These are the comparative sort of a diagram which is being shown here. This is a double headed rail section, where this section and this section, they are of similar nature. It is a little higher than the another rail section, which is the bull headed rail section, where it has a sort of a bull head, that is, it is more stronger, bigger as compared to this foot section. And this is a flat footed rail section, where this top section is more or less a sort of a similar condition as this one, with some sort of a thickness or the depth of the section being reduced, but what we see is that the foot is being enlarged by a big amount. And instead of 6.35 centimeter as a foot being provided here, it is more than double of that one, and this is 13.65 centimeters in size at this level. So, the merits of the flat footed rails are, they are easy to fix, they are more economical, they have greater strength and stiffness, they provide more lateral stability, there is no requirement of keys or chairs which are required in the previous two cases, that is the bull headed and double headed rail sections. The simple arrangements are there at the points and crossings by which the direction of the movement of a train can be made. We will be looking at the points and crossings in some other lecture. But there are of course some of the demerits related to the flat footed rails. There is a demerit in terms of the loosening of the fittings. Because of the thinner sections, there are chances that the fittings get loosened out, and there are some problems related to the straightening of the bent rails. If the rails have got bent due to some of the reason, then it becomes a little difficult so as to make them straight. There are all chances that at the bottom some breakage may take place. Then at the time of replacing of the rails, the problem is because they are not being seated in the chair, so therefore we take out the chair and replace it, but here they have been nailed down to the sleepers, and because they have been nailed down to the sleepers, so all the fittings have to be taken out, and then only these rails can be replaced. And then the next thing is the dehogging or battered rail condition, because at the point of joint of two rail sections, there are chances that the battered of the rail may take place. Battering of the rail means it is taking a nose dive at that location because of the impact of the wheels. Now, if that is going down at that location, then it is to be brought back to its normal level condition, that is what is termed as dehogging, and it is a little difficult condition in the case of the flat footed rail. Now, we come to the standard sections or designations which have been used on Indian Railways or otherwise. Now, there are type of rail sections which have been used, because the British were the people who started the railways in our country. So, they used their own standards, as I have told you in one of the previous lectures, and that is why we had the specifications from the British, that is RBS sections or revised British standard specifications. And in that case, the rail sections were designated as 75R, 90R, 115R likewise. And this 75R means that 75 pounds per yard section, 90R means 90 pounds per yard section, 115R means 115 pounds per yard section. Later on, we had revision of all these, and we are now having on Indian Railways our Indian specifications, wherein we are using again the rail sections being designated in terms of the weight per unit length, but that is being taken as SI unit. And here now we have the two rail sections, one is 60 kg per meter rail section and another is 52 kg per meter rail section. The 60 kg per meter rail section is also termed as UIC section, which is a term which comes from France, and it is Union Internationale de Chemin de Fer. This is what is the terminology stands for UIC section, whereas 52 kg per meter rail section is IRS section, which is Indian Railway Standard section. Then the next type of the rail section which is in use on meter gauge or narrow gauge, they stands with still we are continuing with those standard specifications which came from British, and they are 60R section means 60 pound per yard rail section, 75R section and 90R section as specified before. Similarly, in the case of the rail sections for narrow gauge, it is 50R rail section means it is 50 pounds per yard rail section. So, these are the standard sections which are in use, and this is how they are designated in Indian Railways. Now, if we have to make a comparison of the different type of the rail sections which are available to us, then that comparison can be made on the basis of different factors like strength. Strength means we have to look at the load taking capacity of that section, whether it is in a position to take a much amount of a load. As we have seen in the comparative diagram, what we have found is that the head of the bull headed rail section or double headed rail section has been a little more wider or thicker as compared to the head of the flat footed rail section. So, in that sense probably those have a little more strength, but as far as the base is concerned, then the other one, that is a flat footed rail section, has some more strength. Stiffness is defined in terms of the size of the web and the material or the thickness being provided of the web. So, it is more or less a little comparing condition, but along with the fixation of that rail section with the sleeper, that stiffness can be increased. So, it also depends on the fastenings which is being provided along with the rail section. Then laying and relaying of the rail section, as we have seen during a little smaller comparison as we have done previously between the three types of the rail sections, and we have seen the merits and demerits of the flat footed rail section. The laying and relaying is a little difficult condition in the flat footed rail section, because the fastenings are directly being inserted in that rail section, or they are taking sort of you can say they are just fixing it in a much more higher condition as compared to the previous two cases where they are being placed in a chair. So, you just take out a chair and the rail is being taken out. Arrangements at points and crossings is another important aspect for the comparison, because so as to make a change in the direction we have to look at this aspect. Alignment and stability. Stability is much more in the case of the flat footed rail sections, and because of that there are chances of having a better alignment conditions in this one. Initial costing is another aspect, because the cost is the prime factor of starting with any of the thing, whether it is a laying or relaying of any component or the track. Further, we can make that comparison on the basis of the rigidity of the system, the rail sections, how rigid they are in taking up the loads. Then whether it is possible to make the inspection of those one, what is the ease of inspection, or what is the periodicity with which the inspections needs to be made. So, we have to look at these two aspects. The replacement is to be taken in the form whether it is possible to make a replacement in a easier way, or it is quite difficult to replace the thing. The maintenance aspect is taken in the form that what is the periodicity with which the maintenance is to be done, whether the periodic maintenance is required at a level of weekly or fortnightly condition, or it is to be done at a monthly basis or more than that. Suitability is another aspect, that what are the locations where those rail sections can be easily used. So, whether that suitability is available to all the rail sections or not, we have to take care of that. Now, coming to the next point is the selection of the section. Now, there are different factors which needs to be taken care of in the selection. The very first thing is what are the axial loads which are coming from the top. Depending on the heaviest axial load, we have to use a type of the rail section, and there is a certain relationship between the axial load and the type of the section. We will be looking at that one. The maximum permissible speed is another aspect. If we have to provide higher speeds, we require a better higher level of a rail section. Then what is the depth of ballast cushion? If the depth of ballast cushion is lesser, then obviously a bigger rail section is to be provided. Then type and spacing of sleepers, there is another aspect. If the sleepers are of inferior type, or they are having a lesser of spacing, so that now each sleeper will be having more loads which are coming at that one, then also it is going to create some effect at the type of the rail sections. And this type of relationship we have seen when we have seen the specifications of permanent ways, that if this is a permanent type of way or the route, then what is the depth of the ballast cushion to be provided, what is the sleeper density to be provided, similarly what is the rail section which needs to be provided. Now, here the relationship is being given as I was talking, that the axial load can be related to the sectional weight of the rail, that is what kg per meter rail section is available to us, and the relationship is that the maximum axial load is 560 multiplied with the sectional weight of rail in kg per meter. So, if we are talking about the 52 kg per meter rail, or if we are talking about the 60 kg per meter rail, then that will get multiplied with 560, and it will give you the value of the maximum axial load which it can sustain. So, we can transform this axial load into tons, and that is how the axial load of the locomotive will be defined. So, what type of locomotive is to be used will be defined in this form, or if we have the locomotive and we have to see that what type of rail section is to be provided, then using that axial load of the locomotive we can find out the sectional weight of the rail. So, it is a vice versa condition. The another thing is that how we specify any rail. So, what is the brand of that rail? Now, there are different ways of doing it, but we are using some way, that is it is defined in the form of this line which is being shown here, and this will be engraved on the rail section. It is IR-90R-Disco-2 1985-basic Bessemer. Now, what does it mean? It means IR is for Indian Railways, 90R means it is 90 pound per yard rail section being used here. It may be 60, it may be 75 R. Then TISCO means this is a company which has manufactured this rail section. 2 is for the month in which it is being manufactured. 1985 is the year in which it was manufactured, and basic Bessemer is the manufacturing process by which that rail section has been manufactured. So, this has been the previous way of defining it. Now, there has been a little different modification in this one, and what we have is IRS 52 kg 710 TISCO 2 1991 arrow OB. What it stands for is that it is Indian Railway Standard Specification IRS. 52 kg is the rail section as 52 kg per meter. 1710 is the grade of the rail. There are two grades of the rail, one is 1710, other is 80 grade. TISCO is again the name of the company, 2 is again stands for the month, and the next one is 1991 stands for year, and it says that it is being processed by the process OB. OB is the short form of again a sort of a Bessemer, ordinary Bessemer process of steel making. So, whatever are the abbreviations available, those abbreviations will be used instead of giving the full big name of that one. Similarly, in the case of this 52 kg per meter rail section, it instead of this one as an alternative, it may be 60 UIC rail section, which can be given at this level. So, this is the thing which will be engraved on each and every rail section which is manufactured by any of the company, and this tells us that what was the year in which it was manufactured, and accordingly the replacement requirements can be ascertained. So, the other aspect related to rails is the length of the rail sections. The rails are manufactured in different length. In the case of the broad gauge, it is 12.8 meters, and in the case of meter gauge and narrow gauge, it is 11.89 meters. So, this is the length of rail sections which is used. Now, this is restricted. We are not having a bigger rail section because of certain reasons. The one is that the ease of manufacturing, we can easily manufacture smaller rail sections as compared to the large long rail sections. Other aspect is the cost of manufacturing the bigger rail sections. It is quite large as compared to the smaller rail sections. Then there is a lack of transportation facility of such big rail sections. You require a big wheel base on which those can be transported. Lifting and handling facilities are again of a specific nature because it becomes a heavy weight condition. So, therefore, it may not be available at each and every place. So, it is better to have a smaller rail section as compared to the bigger rail section. Then, if the rail section length is increasing, it is going to also create an effect on the gap requirements to be provided between the two rail sections which are jointed at one level. Now, because of the change in the temperature, there will be contraction and expansion of the rail section, and if the length of the rail section is more, then there is going to be proportionately increasing the movement in that direction, maybe in terms of expansion. So, it means a larger gap is to be provided between the two rail sections, and if the larger gap is being provided between two rail sections, it will be a difficult situation as far as the movement of the wheels is concerned over that. Then heavy thermal stresses on long rails, this is as already discussed, it is going to create this effect in terms of not only the movement of the rail, but also in terms of the gap requirements, especially the expansion gaps which are to be provided. Looking at all these aspects, the length of the rails has been restricted to what we have seen as 12.8 or 11.89 meters in the cases of broad gauge or meter gauge and narrow gauge track conditions. Now, coming to the 90 UTS section, as we have seen that we have two types of the sections which we have been using. One is 72 kg per meter rail section, other is 90 UTS rail section, that is 90 kg per mm square ultimate tensile strength section. Now, this is a heavier, or this is a section which is having a better strength condition. Here the tensile strength is of the amount of 90 kg per mm square as compared to the conventional rail sections which are having the value as 72 kg per mm square, and that is how it is having a better strength value. So, it can be used at those places where the heavy loads are coming or where the heavy stresses are getting induced. Other thing is related to the stresses. In this case, the 90 UTS rail section provides allowable shear stress of the nature of 22.5 kg per mm square. Now, in the case of 72 UTS rail section, the value of the allowable shear stress is 18 kg per mm square. But in the today's condition, when we are having a sort of a box and wagons being used for the movement of the freight, or we are having the heavy loads of the passenger traffic which are moving in certain directions, in those conditions the maximum shear stress are reaching to a value of 20 kg per mm square. Therefore, the 72 kg or per mm square or 72 UTS rail section will not be able to take up these type of stresses, and it is better to shift to 90 UTS rail section in these cases. Another characteristic of 90 UTS rail section is related to its hardness. They are having better hardness. Due to higher hardness value, the resistances of the wear are also lesser. The 90 UTS rail section is having a hardness number of 270 BHN. This is Brinell hardness number, as you must have studied in the previous years. This is the way of defining the hardness based on the indentation in the metal. So, on the basis of that, it is giving a value of 270 as a hardness number, whereas in the case of 72 kg per mm square UTS rail section, this value is 220 BHN. So, it is quite higher as compared to that one. Then the next step, next value which is of advantageous condition to 90 UTS rail section is of its service life. The 90 UTS rail section is having 50% higher service life as compared to the conventional 72 kg per mm square UTS rail section. So, this is another aspect which has a long term effect in terms of its maintenance or the periodicity of the maintenance or the replacement requirements of the rail sections. If we look at with respect to the amount of loading conditions, then what we found is that the service life of 52 kgs of a 72 UTS section is 350 gross million tons of the load in a year, whereas in the case of 90 UTS section with the same of 52 kg per meter rail section, it is 525 GMT. And if we also change the sectional load of that rail section from 52 kg to 60 kg per meter, and still we are maintaining with the 90 UTS rail section, what we found is that the service life increases to 800 GMT. It means in the previous case it is increasing by something like 1.5 times, or in the case of the later one it is increasing more than 2 times. So, this is how the service life has been increased in this section, and therefore, the maintenance requirement of those will get reduced. It has the economical aspect in this sense. So, that is why the 90 UTS section now are more in use in all those track conditions where there are heavy loads moving or there are the differential loads moving in different directions. Then they are also adaptable for high speed tracks or heavy load corridors. They have a lesser wear on curves and gradients. This lesser wear is related directly to the hardness number, as we have seen. It has a higher hardness number as compared to the conventional systems. And obviously, service life, as we have seen previously, is as high as 50 years. Maintenance life is comparable to the life of other components like concrete sleepers, elastic fastenings, etc. Now, this is one more aspect here. Now, the overall system of the track is not a one single component being provided. It is a combination of components. Now, when we have a combination of components, then the service requirement or the maintenance requirement of all those components will be there. And if this periodicity of the maintenance requirement of all those components are different, then it means at one time we have to take out one component, and while doing that the rest of the components also to be loosened out. Then once it is being done, then again the time will come for the second component, then for the third component. It means again and again and again we will be doing the same exercise. Whereas, if all the components which have been at one place, they are having the similar life span, then at one point of a time all of the material can be taken out and can be replaced simultaneously together. So, that is what is the more important, optimized and efficient way of doing the maintenance. and this is possible in the case of 90 UTS section because it has its life which is comparable to other components to which it is being fixed, that is the concrete sleepers or the elastic fastenings. Now, this is one of the biggest advantage in this case. Now, we come to some of the tests which we conduct on the rail sections. The tests for grade 710 rails are the falling weight test, by which we try to find out the fatigue condition of that rail section. The chemical analysis test, so as to identify the proportion of the chemicals which have been used, the type of the chemicals which have been used in the manufacturing of that rail section, and the tensile test, so as to identify the tensile strength of the rail section, so that we can find out what are the stresses which can be taken up by that rail section. In the case of 880 rail grade, there are some more tests other than the falling weight test, chemical analysis test and the tensile test. They are microscopic examination, wherein the microscopic examination helps you to identify the total process by which that rail section has been created or manufactured, and if there is any flaw in that one, then that can be found out. The hardness test is to be done in the case of the 10% of the casted materials or the rail sections, and similarly there is another test which is termed as the hydrogen content in liquid steel test, and this is also to be conducted for a limited cases as 5% of the cast. So, these are related to 880 rail grade section. Now, we come to some sort of the deformations or the defects which may be caused in the rails. There are different types of deformations or defects. One is corrugation. Corrugation is a condition in which at the top surface of the rail section certain irregularities get created. What we found is that at certain locations the material has come out in the form of a small, very small or minute chipping, and that is how that irregularity has been created, or there is a wavy pattern which has been created at the top surface of the rail section, and this is what is the corrugation which is being created. Now, as soon as any rolling stock moves over these corrugated rail sections, what is being observed is that it creates a large amount of noise, and because of this reason that they are creating large amount of noise, they are also known as roaring rails, that is the rails which makes noise. Another type of a deformation which is being observed is hogged rails. These hogged rails, as being discussed previously too, is a peculiar condition which happens at the joint of the rail sections. At the joint of the rail sections, what happens is that because of the loosening effect of, say, the fish plates and the bolts, or because of the loosening effect of the ballast cushion which is being provided around the sleepers below the rail sections or below the sleepers, or because of the uneven levels which have been provided or which have been created in the rail section, whatever wheels are moving at the top of that one, they will strike at one of the rails, whichever is having a higher level. So, because of this striking, the large impact will be created, and this large impact will start moving the rail section in the downward direction. So, there is a downward movement of the rail section at the end of the rail section, and this is what is known as hogged rail. Other cases of a kink in rail. Kink in rail is a case where wherever the joints are there, the two rail sections goes out of order with each other, and that is what is a kink in rail. It is a sort of a condition where the two lines are being jointed together which are at different grades, and that is the point of connectivity of these two lines is termed as a kink, and this is the type of the thing which happens in the case of the rails also if they are not welded together and they have been jointed using the fish plates and the bolts. So, it is you can say is that is a sort of a relative movement of one rail with respect to the other rail in the lateral direction and creating a kink at that level. Then buckling of the rail is related to the effect of the loads which are coming at the top, and due to which the rail goes out of its shape, and there is a sort of a widening of the gauge, or there is a sort of reducing of the gauge because of that buckling of the rail. Damaged rails are the rails which are showing any type of failure pattern. It may be the cracking pattern, it may be the loss of the material, or it may be any other thing which can categorize the rail into the failured condition. So, that is what is a sort of a damaged rails. We cannot use those rails, we cannot remedify those rails. Then there are different types of the rail failures. The rail failures may be caused because of various aspects. We will be looking at all those failures and when we take up in detail the rail failures as well as the wear on the rails. What type of wears on the rails can be there, maybe on the top of the head or the side of the rail head or at the bottom, or what are the reasons due to which those happens and how we can remedify those wears on the rail failures will be of the next aspect which we will take up in some other lecture. Now, looking at all these sort of deformations or the type of the defects or the type of the damaged conditions which can be there, we can see some of the things here, and this one the corrugations has been shown. This is the sleeper and this is the rail section which is being provided here, and these are the corrugations which are being shown. What we see is that this wavy pattern which is being caused here, and this is defining this thing, as well as there is a sort of a spouting condition which is created at the top of this rail section head, which will cause the air being filled in this one, and as soon as the wheel moves on this one, because of this movement of the wheel with respect to this air filled in, there will be a noise get created at this one. So, that is why they are also termed as the roaring rails. Then this is a rail and batter, or the battering of the rail or the hogging of the condition, as we have discussed. It happens at the end where the two rails have been jointed together. So, what we found is that this is the straight profile up to this point, and then it is going down like this. So, this is what is the battering effect on this side, and this is what is the battering effect of this side. So, once this type of a battering effect has been done, then what we have to do is we have to just loosen out these fish plates, and then these have to be dehogged, means it has to be pulled back to the normal condition, so that they becomes in the same level. So, that is the way it is to be done. If it is not possible, then it is to be cut out and another section is to be fitted in. Then these are some damaged conditions where we can see that the whole of the piece has come out in this case, or in this side there is a, from the side it is breaking down, this is at the end it is breaking down, and this is the starting of breaking of the section from this side, or starting of the breaking of the section with respect to the point of connectivity of this web section with this footed condition, and this is the curve of the fillet which will be there at this point. So, this type of failures can also be there, and that is what is a broken base failure. Another type of a broken base failure is where the crack is coming throughout the section, starting from the head, moving through the web and coming towards the foot. So, that is how the total rail section has got divided into parts, and we cannot use this rail section further, it has to be taken out. Then there are chances that the material gets chipped off, and when this material is getting chipped off in the form of a small layers, then that is termed as flecking. So, here this flecking is taking place at this location. Here the location at this location we found is that there is a smooth profile as such, but at this location slowly and slowly this irregularity and this material in the layered form is getting chipped. So, this is another type of damage which is getting created to flake rail section, and also necessitates to remove the rail section. Then here we are talking about the piped rail. The piped rail means it is a sort of a pipe condition which gets created, as we see in this sectional diagram. This is the this material has gone away from each other. What we found is that in the web there is a hole being created in the longitudinal direction. So, in this longitudinal direction, this is how it has come out on this side as a bulging, as well as this is also bulging on this side like this. So, this gap gets created, and this is what is a pipe being created within the rail. The same sort of a condition may happen on this location too. And finally, the other case is the shelling. Shelling is a further bigger case of flecking, where in the case of the flecking, very small particles in the layer foam was coming out of that whatever is the section on which that was happening. But in this case, what we found is a large amount of material is coming out, and when this large amount of material is coming out, this is how it will create a sort of a depression at this top surface, and therefore, if this top surface falls towards the side from where the flanges will be acting, then obviously it is going to create a big problem. The one way of dealing with these type of conditions is that we just change the face of the rail section. So, if in the initial condition this is the inner side of the rail section, then what we can do is that we can make this as the outer side of the rail section, and we can just turn this rail like this, and the outer side of the rail section will become the inner side of the rail section. In that case, then we can use the same rail still for some more time period, increasing the life of that rail section. So, in these all cases, what we have seen is that there are different types of defects which can take place in any of the rail section. So, in that sense, we have checked in this particular lecture the various requirements and functions of any of the rail section. We have also seen that what are the different types of the rail sections which are available to us, and then on the basis of the comparative studies of all those rail sections and the historical background of those, we have come up to use the flat footed rail sections, which are more advantageous as compared to the other sections, though there are still some more problems related to the loosening effects or to the laying and relaying of those systems. And then we have also tried to see the length, the aspects related to the restricting of those lengths, the selection of any of the rail section on the basis of certain factors, and then we have seen the various type of damages which are caused in any of the rail section. So, we will be closing this particular lecture at this point of time, and we will be taking up another component of the track, that is say sleeper, in the coming of the lecture. So, thank you and bye bye.
Thank you.